All right, so we are recording, and let me share my screen. Here we go. Okay, so today we are going to continue our study of trigonometry. So for those that maybe had missed class yesterday, if you haven't gotten caught up yet, make sure you do get caught up, just because everything is builds as you go through the trigonometry stuff. So what we did yesterday, you kind of need to know a good bit of it for today and for tomorrow and next week. So the videos are under announcements. So real quick, I could show you where those are at. If you haven't checked those out yet, when you are absent for whatever reason, just go to announcements on Canvas. And I do have right here lecture videos from Zoom, and they'll just be from the most recent at the top to the least recent as you head down the bottom of the list. So you can see that yesterday's lecture is right here at the top. It's a link on YouTube, so you don't have to worry about opening a really big file. So whenever you're absent, use the videos to get caught up, or also don't forget I have lecture notes. You can find the lecture notes under assignments. Where are they at? There we are. So right here, here are my lecture notes. So you just click on those and the PDF files are there. All right, so here we go with our continuation of trigonometry today. All right, so just a recap from yesterday. We started what is called right triangle trigonometry. All right, so right triangle trigonometry is really the foundation of trigonometry. You have to understand those trigonometric ratios, or trig ratios, it's easier to say, in order to understand all of trigonometry. All right, so just as a quick little review, and then we're going to move on from this. So if you have a right triangle, and let's say this angle here, this acute angle, not the 90-degree angle, but the acute angle is, remember the Greek letter theta. And let's say we have sides, I'm going to make up letters here. Let's do X, Y, and Z. So remember, you have to name those three sides in relation to where they're at. So in a right triangle, the hypotenuse, remember, is always a special side of the triangle. It's the longest side, all right? And in this particular side here, Z is the hypotenuse, or I just abbreviated HYP, or if you just like H, that's fine also. But then we have sides X and Y, and they are situated a certain way. So side X, notice that side X is one of the sides of angle theta, right? And so is the hypotenuse. All right, but once you name the hypotenuse, that's all you can name it. We don't name it anything else. So X is a particular side, which is one of the sides of that angle. So remember, we call that the adjacent side. So side X is what we call the adjacent side, meaning it's one of the sides of the angle. It's a part of it, right? Adjacent means next to or really close to. So in this case, side X is the side that is closest to angle theta, along with the hypotenuse. Now the other side, remember, the side that is not highlighted in red is not one of the sides of the angle. It's across from the angle. So side Y is across or opposite angle theta. So remember, the abbreviations were ADJ, or if that's not short enough, use A. Opposite, we wrote OPP or capital O. Make it look like an O and not a 0. All right, make sure it's distinguished. All right, and the trig ratios. So remember, we have the sine ratio of angle theta, the cosine ratio, and the tangent ratio of angle theta. So maybe for 30 seconds, why don't you look at that triangle and maybe see if you can remember these three ratios without having to do too much work. So take 30 seconds on your own, see if you can write out those ratios for sine, cosine, and tangent. If you're having a little trouble, remember the little acronym SOHCAHTOA? Maybe that will help you. Okay, so let's see what you're coming up with. So remember the first Q here from the acronym SOHCAHTOA, SOH, remember the S stands for sine, and O and H just means divide the opposite by the hypotenuse. So in this case, that would be side Y divided by side Z. The cosine ratio, so CAH, that means the adjacent divided by the hypotenuse, would be X divided by Z. And then the tangent, or OA, means opposite over adjacent. So that's side Y divided by side X. And then remember the other three trig ratios are the reciprocals of what we just wrote. So we have reciprocals, and I guess we could call these the regulars. All right, sine, cosine, and tangent are commonly used, so they're the regular trig ratios. Okay, and then the other three are the reciprocals. So the reciprocal of sine would be z over y, z over x for cosine, and x over y for tangent. Can you remember their names? So maybe see if you can fill in the blanks here on the left side. Which name do we give this first reciprocal? What name do we give the second reciprocal? And what name do we give the third reciprocal? See if you can remember that. Make sure you try to memorize some of this stuff, because when you take calculus, it might not be online. You might be back in the classroom and you can't have the luxury of sitting at home and looking stuff up in your books. So keep that in mind for future semesters, that you might be back in the classroom and those professors may expect you to have this stuff memorized. Keep that in mind. All right, so the first reciprocal is cosecant of theta, CSC. The next one should be secant of theta, SEC. And the last one should be cotangent of theta, COT. All right. All right, so that stuff I think is the most important thing that you should have memorized or at least understood from yesterday's lecture. So today, all right, we're going to be focusing on certainly something that's probably a little more realistic. All right, yesterday we looked at right triangles, but I think we all know that not every triangle is a right triangle. All right, so since not every triangle is a right triangle, our focus for today will be on non-right triangles. All right, now non-right is sometimes referred to as oblique. So we'll be looking at how to solve for sides and angles of non-right triangles. Now, for those that have maybe had trig before, just to kind of like give you a little bit of a forward here, what we're going to be studying here to solve these types of triangles is what we call the law of sines and the law of cosines. So if you've had trig or geometry before and you've learned these, that's what these are applied to. The first thing I want to say here, when we say law, it sounds really fancy, like it's physics. It's really not. These are nothing more than formulas. You fill in the numbers and you solve them. It's as simple as that. That's all these are. All right, so the one thing I want to review first, because it's really necessary, because when you're solving non-right triangles, sometimes you use the law of sines. Sometimes you're going to have to use the law of cosines. They're totally different formulas. So you have to know which one to use. It's not like a guessing game. All right, so if you use the first one for certain types of triangles, the second one might not work with it. All right, so the law of sines will help you solve certain non-right triangles, but not others. And then the law of cosines will solve other types of non-right triangles, but not all types. So you have to know which one to use. And that's what the purpose of the review is is to go over something from geometry to help us figure out what type of triangle we got here. So if you remember in geometry, when you were doing proofs, which we're not going to do, we're not doing proofs here, we used certain phrases and acronyms such as SSS. That stood for side, side, side. So let's call that number one. What that means is that you know the lengths of all three sides of the triangle. All right, and a simple example might be something like this, where we have maybe like 5, 4, and 4. All right, but notice that's all you know. When it says SSS, you know the three sides and nothing else. You don't know any of the angles. All right, so that's what we call SSS. All right, so I don't think we're going to write down a lot more here. Let's just write down the next type, where we have side angle side. And I want to contrast that with side, side angle. All right, because notice there's two S's and one A in each of those. So there's a difference there. So like side angle side would be an example like this, where you know two of the sides. So let's say we know this side is 3 and that side is 6. And the angle that we know would be this angle here. Let's say it's 80 degrees. Whereas side-side angle, so let's use those two sides again. This time, the angle would be either this or this. Okay, so let's say it's the first one. Let's say it's 42 degrees. Now, what's the difference between them? The difference is, in the first one, with side angle side, notice how the A is between the S's. So when you take a look at the configuration that you have here, let me highlight some things. Notice where the angle is. It's at the intersection of those two sides. So in a way, you would say that the angle is in the middle or in between those two sides with lengths 3 and 6. All right? Because these two sides form that angle. So when you say side angle side, these two sides are forming that angle. All right? So side angle side means the two sides are forming the given angle. Whereas in number 3, it's not the case, right? It's the two sides, they form an angle, but you don't know the angle. But you know one of the other two angles. So maybe we should make a little note there about that. So here, we know the angle formed by two known sides. Whereas here, we do not know that angle. But we know one of the other two, namely one of the two at the bottom of that triangle. All right, there's two more that we need to know. One is angle, angle, side, and the other is angle, side, angle. So AAS and ASA. All right, so what does this look like? Well, let's see. So when you say angle, angle, side, that means we know two angles and one side. And here in number 5, same thing, two angles and one side. But the order in which they are configured are different. So here's angle, angle, side. You might have, let's say, this 80-degree angle, this 42-degree angle, and then the side is just not going to be the side between the angles. So notice you have S is not between the two A's, S is to the side of the two angles. So the only side you won't use is this one, not this side, but it's one of the other two. All right, so it could be this one. Let's say it's of length 12. That's what angle side looks like. Whereas with number 5, we have 80 degrees, 42 degrees. This time, it must be this side right here. And notice how that particular S is between the two angles, and this side is also between the two angles. All right? And just to illustrate a little further, we go back to number 4. Just in case you weren't sure, that 12 could also be down here. Okay? It just can't be the side here that I'm noting. Okay? All right, so those are the ones that we need to keep in mind. All right, so just to summarize, all right, so we're going to be looking at, so we will use the number 1, the law of sines for 3 of the above situations. We'll be using it for angle, side, angle, angle, side, and side, angle. And number 2, we will use the law of cosines for the side, or side, angle, side. Okay? So in other words, the law of sines and the cosines, they're different formulas that are set up with different types of information. So like, for example, the law of cosines can be set up using all 3 sides of the triangle. And you can use those 3 sides to find the angles. The law of sines. So for example, we use the middle one, angle, side. That just means as long as we know 2 angles at least, all right, and at least 1 side, then that information can be applied to the law of sines, and you can use that to find other missing sides and angles. All right? So what this little blip right here is, numbers 1 and 2, is just telling you when you can use the law of sines and when you can use the law of cosines. So the question now is, what is the law of sines? So what is the formula for the law of sines? So let's call this Roman numeral 1. So let's get down to business. All right, so the law of sines says this. For a triangle with sides little a, b, and c, opposite angles big A, B, and C, respectively. All right, now the word respectively simply means this. Little a, b, and c and capital A, B, and C, they get paired in order. So like little a gets paired with big A. So that means side A will be opposite angle A, side B will be opposite angle B, and side C will be opposite angle C. Okay? Now here's what the law says. If you take the sine of angle A and divide it by side A, and if you take the sine of angle B and divide it by side B, and if you take the sine of angle C and divide it by side C, these ratios will all be equal. Okay, so let's call this letter A here. All right, letter B. So again, we already wrote this down, all right, where we just used the law of sines. So we use this when, right, we have angle, angle, side, angle, or side, side, angle. Okay, now let's go back to A here. The formula looks like it's got three things to it, right? But whenever you have an equation, you only need two sides. So when you are applying the law of sines, you only need two of these three parts here. You don't use all three parts because you're not going to have enough information for everything. So what you do is you pick the two that have the most information in the triangle. All right, so you pick the two, whether it's the AB or the BC or the AC ratios, you pick the two that contain the most information. So let's write that down. So for C, so in part A, we pick the two ratios that have the most information in the triangle. Okay, so let's do some examples. So let's say we have this triangle here. All right, and let's say we have angles A, B, and C. So notice the capital letters will go outside at the corners. So those are the angles. And let's say we have the bottom side here is 4, has a length of 4. Angle B is 40 degrees and angle A is 45 degrees. All right, and let's say I asked you to find side B. So side B would be over here. So remember here in the definition of the law of sines, all right, the little A, B, and C are going to be opposite from big A, B, and C. So notice opposite angle B would be side B. So can you think about this bottom side here? Is this side A or side C at the bottom? It should be side C because it's across from angle C. All right. So we have here that side C is 4. Angle B is 40. Angle A is 45. Okay. All right, so now I want to find side B. So if I want to find side B, all right, which ratio do you think I must include in my calculation? I probably need to include this middle ratio, sine of B over B. And then, do I use the A ratio or the C ratio for the other side? Well, I have to pick the one that will have all the information known. right? Because in my equation, I don't know little b. So whatever I fill in here, I better know all the numbers, okay? So I'll tell you right now, we'll be using the C ratio, and here's why. You might be looking at the triangle and you might think to yourself, wait a minute, we don't know angle C. We do know angle C. We can find it very easily. So one little note here that we want to make. Okay, is that the sum of the angles of any triangle is 180 degrees. Maybe you remember that from geometry. So therefore, angle C can be found very easily with these two angles, 40 and 45. Right? So if you know that these three angles add up to 180, what you can do is subtract these two from 180, and the difference will be angle C. So it will be 180 minus angle B of 40, minus angle A of 45, and what is that? 95. So what we can do, since we now know that, we can now add that to the diagram. So we know that now, which means you can use it. You can use it. Okay, so now let's go back to our formula that we're going to use. And I just want to make sure you understand this. Okay, so we know angle B, we know angle C, and we know side C. So notice 3 of the 4 numbers are filled in. So therefore, we can use this to solve for side B. You have to have 3 of the 4 numbers filled in to solve this. And we have those 3 numbers. So here we go. So we would take, I'm going to write it down underneath the sentence here. So we would have the sine of angle B, which is 40 degrees, over side B, equals the sine of angle C, which is 95 degrees, over little c, which is the 4. So there's my equation set up. All right, so you set it up. And then, yesterday, if you remember, we were solving the trig equations by cross multiplication. So we will do that again here. That will work. So first, remember cross multiply means to multiply diagonally. So I get B times the sine of 95 degrees equals 4 times the sine of 40 degrees. Okay. All right, and then next, get B by itself. So isolate B. Oh, I can't spell. That's terrible. Look at that. So isolate B. So remember, this sine of 95, remember, it's just a number. This whole thing is a number that your calculator knows. Okay? So you divide both sides by sine of 95. Divide that by sine of 95. That will be 1. So we get B times 1 is B. And then whatever this is, 4 sine of 40 degrees, divided by sine of 95 degrees, whatever that is our answer. So now you go to your calculator and get the answer. For those that weren't with us yesterday, or for those that maybe weren't paying attention at this point, don't forget the first thing you need to do is set your calculator to degree mode. Degree mode. All right, so you hit the mode button here, and then you just scroll down to the word degree, hit enter, and you're in degree mode. All right, because there's different types of angles. There's angles in degrees, and there's angles in other measurement systems. So you have to, you have to tell your calculator which measurement system you're using for the angles. And we're using degrees in this problem. So we got to do 4 times sine of 40. Close the parentheses after that 40 or you're going to have problems. Divided by sine of 95. Close the parentheses. Bam, those are answer, about 2.58 or 2.6. Okay. All right, let's do a part 2. So now let's find side A. Or no, yeah, side A. So using the law of sines, if you want to find side A, you definitely need the first part of your equation has to have the A's, right? You got to have A in there somewhere. So we take that from our formula in the box here, right? You take this part, and then you choose one more so that you know the numbers. All right, so choose one more where you know all the numbers. So let's see. We know all the C's. Let's use the C's. So if we use sine of C over C again, we could do that. We also know the B's. We could use the B ratio as well. But the only thing I wouldn't like about using the B ratio is that the 2.6 was rounded. It's not an exact answer. So you might have some error in your answers by doing that. All right? All right, now you fill in the numbers. So we have the sine of A. What was A? 45 degrees. Over A, which we're finding. And then we have sine of 95 divided by 4. So now that's set up. All right, remember the next step is to do what? Cross multiply. So diagonal multiplication, we would get A times the sine of 95 equals 4 times the sine of 45 degrees. And then the last step is to isolate A by doing what? Dividing the sine of 95. So I get A equals 4 times the sine of 45 degrees divided by the sine of 95 degrees. And then we're going to round that using the calculator. All right, so let's do that on the calculator together. So we would have to do 4 times the sine, or just 4 sine of 45. And don't forget, close the parentheses. Close the parentheses. Divided by the sine of 95. Close. Whoops, forgot the 5. Thought I hit the 5. There we go. So that looks like it's about 2.8. 2.8. All right, so example number 2. So I'm setting up my triangle here with two angles of 140. And then over here, we'll have a side with a length of 2. And now let's label the angles with letters. So let's have this as C, A, and B at the top. So which side is the side with a length of 2? Is it little a, B, or C? Remember, it is across from angle C. So therefore, this 2 here is opposite angle C. So that means side C is 2. Angle B is 100. Angle C is 40. Now, of course, let's make our first question here to find angle A. Now, that's really easy to do here because we know the other two angles. So we can use that rule that I gave you where you just take the two angles that you know, subtract them from 180, and the difference is the third angle. So in this case, it will be 40. Right, because we're subtracting 140 total, so the difference would be 40. So therefore, angle A, which we now know, is 40 degrees as well. All right, now once you find something, you might as well add it to your diagram because now you have more information. You have more information. Okay? Now, if we ignore this 40 degrees that I just wrote in here, this configuration that I have here, by the way, is angle, angle, side. Did we do that in the first problem? I don't think we did. No. All right. 95 wasn't there originally, but the 40, the 4, and the 45 were. This was angle, side, angle. All right. So problem 1 was angle, side, angle. Problem 2 is angle, angle, side. All right. So part 1 is done. Part 2. Let's find side A. So where's side A at? I didn't label it, but hopefully you can figure out that it's this side right over here, all right, between angles B and C. So if I want to find side A using the law of sines, because it's angle, angle, side, all right, I must use at least this A ratio. I have to use that if I'm going to find side A. Now, which ratio should I use over here, the B's or the C's? All right, now remember, you have to know both for the right side because I already don't know side A. So I have to make sure that whatever I put here is already numbers. So it'd have to be the C's because we know side C and angle C. So here now we just fill in what we know. We would have the sine of 40 over A, which we're finding. And then we would have sine of C, so sine of 40 again, over what? 2. Now this one here, we're not even going to need the calculator because when we cross multiply, we get 2 sine of 40 equals a sine of 40. Right? And the A and the 2, doesn't matter which side they're on. And then when you divide both sides to isolate A, we're going to be dividing both sides by the expression there where A is, divide by sine of 40, divide by sine of 40. All the signs cancel out, and your answer is right there, 2. Okay? So now that's an exact answer. We didn't have to round this. So that side up there is now 2. So I want to point out something now that we should have guessed from the beginning here. When you have two angles that are the same, like 40 and 40, you're going to end up with two sides that are the same. And if you remember, this is what we call an isosceles triangle. And that just means you have two sides and two angles that are equivalent. All right, and finally, let's find the last missing side here, which would be side B. All right, so now think about what ratio you have to use. If you want to find side B, you have to at least use this ratio, sine of B over B. And then we might as well use the C ratio again, because we know that we know those values. All right. So now if we fill in the three numbers, angle B is 140. Side B, we don't know. We're finding it. And then the C's, we already did that up here. That's the sine of 40 over 2. All right, and just as a quick review from yesterday, remember, so when you're looking at like these numbers here, like 2 and 40, remember you can't reduce those.
Angle B is 100, I think, not 140.
Oh, thank you. You are right. Good
You're
job.
welcome. I just thought that would screw you up.
It definitely would. Thank you. Someone's paying attention. I'm very happy about that. Okay. I'll move this up a little bit and then we'll continue. All right, so it's set up here, right? We have 3 numbers filled in and there's only 1 remaining, so we can solve by cross multiplying. So we do b times the sine of 40, 2 times the sine of 100, and then isolate b, just divide both sides by sine of 40, sine of 40, and of course the sine of 40 over sine of 40 cancels out completely as 1, right? So we get b equals whatever this expression is, all right? All right, and then of course the calculator will crunch those trig numbers for you. All right, so let's do that together. So we'd have 2 sine of 100, close the parentheses, divided by the sine of 40. And then you have your answer of, let's say, 3.1. In case you're wondering, I use parentheses here in the last step. You don't have to do that. Sometimes I do that just as a reminder that a number like sine of 100 is its own number. You can't mix it with anything. So like that 2 there, you can't make this 200 degrees by multiplying. All right, the sine of 100 is a completely separate number. That 100 is part of the sine ratio, so you can't bring in other numbers. And just like same thing like up here, you can't divide these numbers. This 40 is not by itself. 40 is actually inside the function sine. So in a sense, this number is kind of trapped here, and you can't divide it by 2. All right. So just remember that outside numbers can't go into the trig values. Okay, so what I would like to do next is switch to the other handout, the plots for the week. Because on there, we have a little bit of a word problem where we would have to apply the law of sines to solve a particular problem here. So let's see here. So this is on page 4 of the handout if you're referring to it. All right, so let's take a look at the problem. And of course, you notice that it's overlapping triangles here. So it's going to involve more than one step to find what we're looking for. So what we're looking to do is to measure the height of a mountain. So you see here, we have a mountain, which doesn't look very big, but it's not drawn to scale. So you have the height here, which we're going to have to find by adding 2 things together. So first we have a surveyor, and a surveyor it's a particular job where you do things like this. You stand away from something at a distance and you use these devices, which I forget what they're called, but they help you figure out the angles that something is positioned from where you're standing. So in this case, we're looking at angles of elevation because these people are looking up to the top of the mountain. All right, and you have to do it from 2 different positions. So this person here and that person there are the same person, but they're taking 2 different measurements. And notice here that they're 900 meters apart between those 2 different measurements. So at this point, this person's looking up to the top of the mountain at a 47-degree angle, but when they move back, the angle is a little less. And you can use these 3 numbers, the 2 angles and the 900 meters, you can actually use that to solve the problem. And you will need this 2 meters, which is the person's height. Okay, so let's take a look at how we're going to do this. So first, notice that the height needs to be broken up into 2 pieces. All right, the bottom piece we already know. That's just the 2 meters height of the person that is taking these measurements, this surveyor. So we can just simply walk that person over here, and it's still going to be 2 meters plus whatever remains. So let's call this x. So the height of the mountain is going to be x plus 2. Right? Just add the 2 pieces up, and that's the total height of this mountain. Right? That's what we want. All right, so how are we going to do it? So if we start with the 47-degree angle, all right, notice there's a right triangle that's formed by it, but we don't know anything else about that triangle. All right? So the 47-degree triangle there doesn't have enough information for us to do anything with that much. So let's bring that down. So we have there, it has a side of x and a 47-degree angle. But the problem with that right now is there's not enough info to solve this. Remember with trig ratios, they involve at least 3 numbers. And right there, we only know 1 number and the right angle. So that's really 2 numbers that I know. So I need to know at least 3 for a trig ratio. All right, and we don't have that. Okay, but what else do we have here? We have another triangle, this 35-degree section. Okay, where we have the 900 meters, the 35-degree angle. All right, and even there I have 2 numbers. And it might look like I don't have enough information, but guess what? We actually do. We actually do. So what we want to find is actually this angle here, which is this. So when you look at the diagram, what shape does the 47-degree and the red part make? That's a half circle. So remember from yesterday, we talked about supplementary angles. Those are 2 angles that will form a half circle or 180 degrees when you rotate the 2 together. So this 47-degree angle and this unknown angle here, this obtuse angle, will add up to 180. All right? So therefore, that means this angle here would have to be 133 degrees, because 133 plus that 47 will give you 180. And now, of course, now that we have those 2 angles, we could also find this 3rd angle at the top, because we're going to need it. The reason why we need it is because the side of 900 is opposite that angle. So remember, with the law of sines, you're going to need a side and its opposite angle. So that's this angle at the top, which is what? So we'd have to do, let's call this angle A. So angle A would be 180 minus 35 minus 133 degrees, which would be 12. Right, so that's 180 minus 168. So that's 12 degrees. All right, now you fill it in because now we know it. Okay, so now what we're going to do, we're actually going to find this top side here, this dotted side, because then once we solve for that, then we're going to use the entire diagram as one big triangle to find this missing side of x. All right, so notice that. Let me clean this up a little bit, and I'll point out some things. Let me get rid of these, get rid of this, and that. So what we're going to do first is find that. So let's mark that with a little Roman numeral 1. We're going to get that first. All right. And then once we find that, then we'll be able to get this x here. So that will be our second task. Now, why does finding this side work? Well, for step 2, we're going to be using this whole right triangle to do this. So notice that this whole right triangle, if I bring it over here, we'll have an angle of 35 degrees. We'll have part 1 solved, and then we'll have to find part 2. And notice that's a right triangle with an opposite side and a hypotenuse. So I could just use the sine of 35 and opposite over hypotenuse to solve for part 2. All right, so that would be what? Part 2 over part 1. And then I can solve for part 2 once I get part 1. But notice that my final answer depends on part 1. So I need to get part 1 first. All right, so let's do that. Let's solve for part 1 right here. So let me move this up. All right, and solving for part 1, we're going to use the law of sines. Because first off, this triangle here is non-right. All right, there's no right angle. So I would need the law of sines also because I have angle, side, angle information. Right, look at the bottom of the triangle. That's angle, side, angle. All right, it's also technically angle, angle, side. So you might be thinking that. So it's actually both. It's angle, side, angle, and angle, angle, side. So I need the sine of 133 over, so let's call this B. All right, so that would go under there because this side B is opposite angle of 133 degrees. And then we have the A ratio. We have angle 12 degrees, and its opposite side is 900. So I would do the sine of 12 degrees over 900. All right, now cross multiplying, we get B times the sine of 12 equals 900 times the sine of 133. All right, cross multiply diagonally. All right, and then get B by itself. So you take 900 sine of 133 degrees, and we're going to divide it by the sine of 12. And that will solve part 1. And let's round it a little bit. So 900 sine of 133 divided by sine of 12. So 3165.9, let's say. 1 decimal is usually pretty good. When you get answers like this, you should at least use 1 decimal place. Okay, so there's part 1. All right, now part 2. All right, so just as a reminder now, part 2 is what I pulled out of here, these 3 red highlighted sides, all right, the outer edges of this whole problem here. Remember that this inner triangle, there wasn't enough information at all there. I only knew 1 or 2 numbers. So it just wasn't enough information to do anything with the 47-degree angle. All right, you only needed the 47-degree angle to get this 133-degree angle over here. That's all that was useful for. So now for part 2, this is a right triangle. So that means you can use right triangle trigonometry. So we already said up here, we're going to use the sine ratio because the 2 sides of interest are the opposite and the hypotenuse. So I would do the opposite, which is unknown, right? So that's our 2 there, over our side of 1, That's the hypotenuse of 3165.9. Okay? And that's because this side here is this side here, right? And that's the 3165.9 that we found. You just carry it over. All right, so remember what you do from yesterday? You put the left side over 1, we cross multiply, right? So that, remember, that's really just an unknown side. So our side, Roman numeral 2, times 1 is Roman numeral 2. And then we get 3165.9 times the sine of 35 degrees. All right, and that will give you 1815.9 meters. All right, and that part was in meters also. All right, so finally, now remember we wanted the height of the mountain, which is adding together, all right, the value of x, which is, that's our Roman numeral 2. So that would be 1815.9 meters, plus the 2 meters height of the surveyor would be 1817.9 meters total. Okay, so the trick with problems like these certainly is, deciphering the diagram. All right, and typically diagrams like this, all right, there's really typically 2 or 3 triangles. In this case, there's 3 triangles in this diagram. There's the 2 that clearly stand out, and then there's the bigger triangle that contains both of the 2 smaller triangles. All right, and in problems like this, typically you need to use 2 of the triangles in a 2-step process to get your final answer. And the third triangle typically is really not very useful. Okay, so that's the one thing you have to figure out, is which one of those 3 triangles has the least useful information. And in this case, remember, it was this one right here. So that means you can kind of just rule that one out and not worry so much about it. All right, and in a problem like this, when you have multiple triangles, chances are you have to do 2 steps to solve it. All right, not 1. So they're a little tricky that way. All right, so I think what we'll do right now is do our first group work. Let's do that. All right, and the first group work, if you haven't downloaded it, it is under group works where it normally is, under labs rather. And you'll be doing number 1 only, using the law of sines to solve. All right, and also make sure you label each one with AAS, ASA, or SSA based on the information that's given at the start. All right, and in these 3 problems, you don't have to solve for everything. Notice problem A, I'm only asking you to find the length of side B. That's it. You don't have to find anything else for credit. For part B, just find side A for me, which I labeled for you. And part C, find angle C for me. Okay, find angle C for me. C is a little bit of a, I don't want to say it's more challenging. but it's a little different. You still use the law of sines, and I'm going to leave it up to you to figure out how to find angle C. And I'll give you a hint. You might need a trig inverse for that one. Okay, so you'll do numbers 1, A, B, and C. Let's just do that for 10 minutes. Because these shouldn't take you long at all, because you're only solving for one quantity in each. So we'll do 10 minutes, and then we'll come right back. All right. For group work number 2, just to give you a heads up, I'll make that a 30-minute time. This way you have a much longer break. But we're not going to be that far from doing that. All right. So let me set up your groups for 10 minutes. I'm going to pause and share the screen as well. All right, so in 1C, this is the problem. And we had 3 sides labeled and 1 angle. So you could have said this was a couple things. You could have said it was side, angle, side, if you look at the numbers up here. But also, you know, all 3 sides. It's also SSS, all right? But right now, we've only learned the law of sines. So that's all we're going to apply here is the law of sines. If you remember, SSS is for the law of cosines. So we could use that here, which if you've never been taught it, you don't know it yet. So we'll use the law of sines for this problem. Now, the 2 ratios that I chose were the C's and the A's. I chose the C's because I'm looking for angle C, and I chose the A's because I know them. I know both of them. So let's set it up. Angle C is what I want. Side C is 20, equals the sine of angle A of 82 degrees over little a of 29. And then you cross multiply. So we get 29 times the sine of angle C equals 20 times the sine of 82. And then we got to get sine of C by itself. Remember, sine of C is one whole function. All right, that whole thing is one piece. So I can only move over 29 by dividing. So if I divide both sides by 29, the 29's cancel, and I get the sine of angle C is equal to 20 times the sine of 82 over 29. So remember, the last thing that we learned last night was trig inverses. So we're going to say we're going to use a trig inverse to get angle C by itself. So remember, what does that mean, a trig inverse? Remember, that's the function where you have a little -1 on top of it. So remember, that sine to the -1 is actually read as the inverse of sine, right, or sine inverse. So you take that on both sides of the equation. So you just write it in there on both sides. All right, so what I just did there, that's called taking the sine inverse of both sides. All right, both sides of the equation, right? So remember, whatever I do to one side, I have to do to the other. We got to balance this thing. And remember here, sine inverse and sine cancel, and that will give me just C. And then this is, well, whatever that is. So let's round it to a whole number angle value. So we'd have to do, clear all that. So remember, sine inverse is this little figure here on top of the sine button. So you got to do a second sine. Second sine of 20 times the sine of 82, close parentheses, divided by 29, close parentheses. All right, then you hit enter, and the angle there, let's say, is about 43 degrees. And there you go. Angle C is 43 degrees. All right, so hopefully A and B were no problem. I'll leave those up to you to figure out if you didn't get to finish those in time. So now we're going to continue on to the law of cosines, Roman numeral 2. And just like the law of sines, this will also have 3 parts. All right, 3 parts. All right, so first, here is the definition or the formula. So again, for a triangle with sides of little a, b, and c, and their opposite angles, big A, B, and C, respectively. So again, that just means little a goes with big A, little b goes with big B, and little c goes with big C. And here's what the law of cosines says. So first we have a squared equals b squared plus c squared. Notice these are lowercase letters here, little a, little b, and little c. Now, this looks like the Pythagorean Theorem. And this is actually a variation of the Pythagorean Theorem, but there's more to it. So it's b squared plus c squared minus 2 times b times c times the cosine of angle A. All right, so notice, what does this involve? It involves sides A, B, and C. So it involves all 3 sides and 1 angle. So you have 3 sides and an angle. Now, you could also write it in a different order. Notice that this one, it has all 3 sides, but it only has angle A. Well, what if you need angle B? How do you solve for angle B in this? There's no B. There's no angle B. So it actually becomes this. You get b squared equals a squared plus c squared minus 2ac times cosine of angle B. So a little rearranging of the letters. I mean, that's the simplest way to explain it. It's not the mathematical way, but the simplest way to explain it is just the letters rearranged in a certain way. Now, what if we needed angle C? Angle C is not in either of these two. So maybe you could take a minute on your own and fill in the blanks. Fill in all of this here. I gave you cosine of angle C. Maybe you could fill in the rest. Take like 30 seconds there to see if you can fill it in based on the patterns above. There's a pattern. All right, so hopefully you were thinking c squared over here. And then in between, hopefully we're thinking a's and b's, right? So a squared plus b squared minus 2ab. All right, so do you notice the pattern there? Notice like at the beginning, like if you look at the first one, we have a at the beginning and a at the end, but no a in between, right? So you have a at the beginning and a at the end for the first equation, but then the b's and the c's fill in these parts here. The second one is similar. You have b at the beginning and b at the end, but a and c fill in the rest. And then here you have little c and big C beginning and end, all right, but a and b fill in the rest. So that's one way of thinking about the pattern there. All right, so let's call this part A. So part B, we use this for when we have, remember, side, 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 or side, angle, side. That's how you know you can use the law of cosines. And it kind of makes sense with side, 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 right? Because when you take a look at the formula, all of these involve all three sides. So that means I know all three sides, so therefore I would be finding an angle. So side, 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 this would be finding an angle. Because in each of these you have three sides and an angle that get filled into the formula. But here we have side, angle, side. So we have the angle, we have two sides. This would be finding a side. And then going back to part A, okay, let's see. Okay, so I had to unshare my screen for a second. All right, now we're back. All right, so going back to part A, there's three equations, but you only have to use one per problem. Okay, so you only use one equation per problem. All right, so let's do some examples. And then we're going to do our group work with a 30-minute time so that we can also have a little bit of a good break. All right, so let's say, for example, we have this, example 2. That's not example 2, that's example 1. Maybe I need a break. All right, so let's see. Example 1 looks like this. Sorry, my drawings are terrible. And let's say we have this side is 3, this side is 4. Let's say this angle is 30 degrees. So hopefully you can see with that much information right there, this is side, angle, side. All right, and let's call this angle A, B, and C. And let's say I asked you to find side A. Well, how do I know it's side A that I have to find? Well, remember the whole idea here with opposite sides and angles. So if you come out from angle A and you go across, that side across from angle A, this is side A. So therefore, I know the other two sides. So side B here is the 4 because it's across from angle B. Also, if you look at angle B, it stretches out to the side of length 4. So we have little b is 4. Side C, therefore, would be the 3. And of course, angle A is 30 degrees. Now, which formula do I use? Which formula do I use? I don't necessarily always have to use the one that has side A as the first letter, because side A is in all three formulas. The second formula is no good because it uses angle B. I don't know angle B. The third formula is no good because I don't know angle C. So in this problem, we have to use the first formula because we know angle A. We have to use this first formula. Okay? So the angle determines which formula you use. So if you have angle A, you use the first formula. If you have angle B, you use the second formula. If it's angle C, you use the third formula. Okay? So let's set this up. So the first formula is being used. And it's cosine A. All right, now you just fill in the numbers and then we'll see where we go there. So finding side A, that means this little a here is A. We don't know it. And then B squared would be 4 squared. C squared would be 3 squared minus 2 times 4 times 3 times the cosine of 30 degrees. Okay, so now it looks like this problem here, all the work for the most part is the right side of the equation, because everything on the right side is numbers. So we get what? 16 plus 9 minus 24 times the cosine of 30. Okay. And I don't have to go too much further with this because let's see, I get a squared equals, well, that's 25 minus 24 times the cosine of 30. And at this point, I can't simplify anymore by hand. I can't do 25 minus 24. You can't make that a 1. Why? Well, that's because the 24 has to get multiplied to the cosine first. So just remember that this 25 and 24, you can't subtract those. Remember the order of operations, my dear Aunt Sally? You got to multiply first before you subtract, right? You got to multiply first before you subtract. But at this point, cosine of 30 isn't a number you might necessarily know. So now all you need to do is take the square root of that, right? Because it's a squared. So if you take the square root, that will give you a. And how are we going to do this? On the great old calculator. So we have to do the square root of 25 minus 24 cosine 30. And there's our answer of 2.1. Oh, by the way, the square root symbol, if you didn't see me, if you didn't see the buttons move, you have to hit second and then this x squared button here because there's a square root symbol above it. All right, so second and then the x squared button will give you a square root over everything. If you remember your algebra, you can also use an exponent of a half for the square root. So like, for example, I could do parentheses 25 minus 24 cosine of 30, close all the parentheses, and then raise it to a power of a half. So if you remember your algebra, a power of a half is also a square root. So it's the same thing. Okay, so there's two ways you can do a square root on your calculator. All right, so there's our answer to that problem there, 2.1. Let's do example number 2. All right, so let's say, for example, we have this triangle. All right, let's say we have an angle of 120 degrees here at angle B. And then the two sides that we have are, let's say, 10 and 14. So based on the angle B here, if we go across out of the angle there, all right, angle B stretches out to this bottom side, so that would have to be side B. All right, and let's say this is angle A and that's angle C. Therefore, this would be side A, 10 would be side C. And that's again because the side of 14 is across from angle A. It's opposite angle A, so 14 is side A. Same idea for C. Now, we know angle B, so therefore, the law of cosines that I will use, all right, is the second formula, b squared equals a squared plus c squared minus 2ac times the cosine of angle B. And again, I'm choosing that one based on the angle, right? We have angle B, we have to use the second formula. All right, now fill it in. So we have b equals, or b squared equals 14 squared plus 10 squared minus 2 times 14 times 10 times the cosine of angle B is 120 degrees. Now let's do this one a little faster. You know, I was being a little picky in the first problem where I had us do a little bit of arithmetic first, where we squared and subtracted a little bit, right? You don't really need to do that if this is eventually going to be a calculator problem anyhow. So let's skip that nonsense and let's go right to the answer. I know that I'm going to be taking the square root of whatever all this is anyhow. So what we could do is just leave it alone. Right? Take the square root of it all and let the calculator do all of the work, every single bit. All right, so if you have a calculator in front of you or on your computer, why don't you do this one on your own for 30 seconds, punch the numbers in, and let's see if we get the same answer. All right, you should get 20.9. All right, but try it on your own and make sure it works. All right, and let's do one more example here with a side, side, side example. So let's say our triangle is this. So let's use sides of 4, 5, and 8. And let's call the angles, we'll put A on top, B and C down there. All right, so you see why it's side, side, side? Because we know all three sides. So what do you think we're going to be solving for here? Angles, right? Angles. So let's first write out what the side letters are. So which one is A? Hopefully you're thinking it's 8, right? Because that side of 8 there, the bottom side, is across or opposite angle A. Side B is over there at 5. And side C, of course, would have to be the 4. So let's find angle A. So let's make that our part 1. And then part 2, we'll find C. So if I'm finding angle A, I have to use the first of those 3 formulas. I have to use A squared equals B squared plus C squared minus 2BC times cosine of angle A. All right, I have to use that A there so that I can find angle A. Now I'll just fill in all the sides, right? A is 8, so we get 8 squared equals 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of A. Now here you do have to do a little bit of work. Okay, so you might as well simplify a little bit, and then we have to isolate the cosine of A as our first step there. And then we'll have to do a trig inverse to get angle A. All right, so let's see. We have 64, 25, 16, and then we have what times cosine there? That's 40 times the cosine, right? 2 times 5 times 4 is 40 with a minus sign in front. All right, so then what we can do next is I can add 25 and 16 because those are just 2 whole numbers sitting there, right? That's 41 minus 40 cosine of A. Remember that that 40 is multiplied to the cosine, so you cannot subtract 41 and 40. However, My Siri must have thought I was talking to it. All right, however, you can subtract 41. And then that leaves you with minus 40 cosine of A. And then you can divide by the negative 40. That'll work. I can divide out a number from a multiplication. So here I get cosine of A equals what? On top, I can subtract and get 23. And there's a minus 40 down there. So that means my whole fraction is just a negative value. All right, and then we take the cosine inverse of each side. All right, remember the cosine inverse is what we use to get an angle by itself. All right, so you cancel out the cosines with a cosine inverse, and that will give me angle A. And then this expression we do on the calculator, cosine inverse of negative 23 over 40. Let's do that together. So we do second cosine. All right, and now if you look on your screen, if you're looking at my calculator, there are two minus signs here. There's this subtraction minus sign, and we have here the negative sign. We have to use this one here because we're not doing subtraction in this expression. We're just entering in a negative number. So we have to use this negative sign here in the parentheses. And then type in 23 over 40. And then the answer there is about 125 degrees. All right, part two, let's find angle C. So if you want to find angle C, you have to use the third formula with side C squared equaling A squared plus B squared minus 2AB times the cosine of C. All right, and now we're filling in all the lowercase letters there. So we would have little c is 4 goes on that side. And then a squared is 8, so 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of angle C. All right, now, the next thing here, all right, kind of like what we did with the problem above, let's see if we can just, for the most part, get the calculator to do most of this. So like over here on the in the first part, maybe you didn't like all the arithmetic. So what we could do is just skip all the arithmetic and do this. Move everything to the left side so you can isolate cosine of C. All right, we want to isolate this cosine. So what do I need to do that? Well, I need to move 8 squared over, and I need to move 5 squared over. So I can do 4 squared minus 8 squared minus 5 squared. Now also remember, these three numbers here, the minus 2 times 8 times 5, are multiplied to the cosine. Remember, they are multiplied. So you can't add that to the other side. You have to divide this multiplied set of numbers, all right, to the left side. So you would divide by negative 2 times 8 times 5, and that will isolate the cosine. So if you want to do it that way and then just let the calculator do the rest, that's fine also. Okay? But if you do simplify it, you should get negative 73 on top and negative 80 underneath. If you want to simplify it, that's fine. I don't think you really have to, because you're going to enter this into the calculator anyhow. And also remember, these two negatives become positive. So that's really positive 73 over 80. So then you take the cosine inverse of each side, and it simplifies to this. and then rounding it will give you 24 degrees. And I decided we're going to do a part 3. Find angle B. Now notice I left a very small space for this. And that's because you don't need to do all of this to get the third angle. All right. The one thing you have to remember, all right, is the law from up here, right here. The sum of the angles of any triangle is 180. And that rule is super easy to use when you know 2 of the angles. So now in this problem that we just completed, we know 2 of the angles. So this is easy for this part. So it's only 180 minus angle A minus angle B. The law of cosines can be used. You should get the same answer, but it isn't necessary. It's a longer, unnecessary method. If you have something easier that you can use it. All right, so what is this? That's 180 minus 149. So that's a difference of 31 degrees. So angle B is 31. And then notice if you add these 3 up, 24 plus 31 plus 125 is a total of 180. Okay. All right, so now we're going to do our 30-minute groups here, where you're going to do, I think it's just problem 2. Yeah, just do problem 2, A and B. So let's just take a gander at it real quick. So you're using the law of cosines to solve. Make sure you label it with SSS or SAS based on what the information is. And each of these is just a 1-part problem. In this problem, you only have to find side A. And in part B, you only have to find angle B. You don't have to find anything else. Okay, so that makes it a little quicker. All right, so you'll do problem 2, parts A and B, and you have 30 minutes to do this, which you're not going to need 30 minutes. So have a good break as well while we do this. So I will share my notes with you, and we will continue here with our study of trigonometry. Let's see. All right, I'll share my screen with you, and here we go. There's my notes. Okay, great. Okay, so what I would like to start with is I would like to finish off the last problem here from the plots for the week. And this just involves a little application of the law of cosine. So we'll pick up with that, and then we'll go into the last part of our lecture here. So this is a little application here in anatomy and also forensics, where you can, when you look at the remains of a skeleton, and you want to try and figure out is, the person's remains that you found there, is it a man or a woman, male or female? And of course, there's biological differences between the genders and their skeletons and their bones. So let's take a look at that, and then we'll answer question B here to determine if the particular, I guess it's a femur, if it belongs to a man or a woman. So we have here, it's called the Precalculus triangle. I don't know if I pronounced that correctly, but Precalculus triangle, located at the proximal end of the femur. has been used to identify the gender of fragmented skeletal remains. So we are given that, now remember in geometry, this means the side AB, right, or segment AB is 30.1 millimeters. So that would be this little piece right here. AC is 51.4, so that would be here. And angle A is 89.2 degrees. So that would be this angle here. In the diagram there. Find the length of B to C. So that side there is what we're finding, and it's across from angle A. So we're going to call that side A. So for part A, all right, we just need to use the law of cosines. And since we have angle A, we're going to use A squared equals B squared plus C squared minus 2BC times the cosine of angle A. So side A squared would be B squared, which is 51.4, plus C squared, which is 30.1, minus 2 times 51.4, 30.1, and the cosine of angle A, which is 89.2 degrees. All right, now, it looks to me that at this point, all the numbers are on the right side, and what we're solving for is already isolated on the left side, but it's squared. So this is one of those where you'd have to do, all right, the square root to both sides. So we need to do the square root of everything that's right above it. So this, I would just have to type into the square root. Look at that laziness. All right, and then just do that on the calculator. And then we're going to get something in millimeters. So let's do that. So that would be the square root of, so it's 51.4 squared plus 30.1 squared minus 2 times 51.4 times 30.1 times the cosine of 89.2 degrees. Hit enter, and it's about 59.2 millimeters. All right, so now let's answer question B. So if the average length of BC, which we just found, right? BC is what we just found. If it is on average 59.4 millimeters for males and 53.3 millimeters for females, which gender would be identified with this measurement here? All right, and of course, the one that's closest is what you would go with. So we would say male, all right, because 59.4 and 59.2 are almost the same number. So this particular femur here is a little bit bigger, so that would correspond to the remains of what used to be a male. Okay, and that's it for that problem there. All right, so let's go back to my notes here. Here we go. All right, so now we're going to go to part 3 of the lecture, where we're going to be talking about two things. So for the remainder of the lecture, we're going to be talking about graphing angles, meaning we're going to draw them. But we're going to draw them with an X and a Y axis. And then the second thing we're going to do, remember yesterday I mentioned how angles are measured in 4 different ways. You can use degrees, but today we're going to learn also a little bit about radian angle measurement. All right, so radians is kind of like degrees, where it's a measurement of an angle, but it's a measurement in a different system. Okay, so let's start with graphing angles. All right, so what we're going to do is we're going to graph these in the XY plane. So in other words, it's an X and a Y axis. All right, now the way we graph an angle, remember it always has two sides and one of them just rotates, the other one is fixed. So the fixed side would be this side. So we call this the initial side of the angle. And then the other arm of the angle will rotate either clockwise or counterclockwise. So the terminal side, actually, let's go back. So the initial side of the angle rests on the positive x-axis, which means to the right. And then the terminal side of the angle, right, does one of two things. It either rotates counterclockwise, which makes it a positive angle, or it rotates clockwise, which makes it a negative angle. Okay, so for example, I could just rotate the angle to there. And remember, we put that little rotational arc there just to show that the angle is actually rotating. All right, and this is what we call the terminal side. Right, because initial is like, this is where you start. Terminal, this is where it stops rotating. That's the idea. All right, so for example, first we're going to look at angles between 0 degrees and 360 degrees. Because we know that angles between 0 and 360 are on a circle, right? 360 is the full circle, 0 is nothing. So how would we plot, let's say, 90 degrees and negative 90 degrees? How would that look? Well, I will show you. So you would start by putting one side of the angle to the right. And remember, 90 degrees forms that nice corner. So if I were to get a positive angle, 90 degrees is positive, so I would rotate counterclockwise, CCW. So that means I would rotate it right up here to the y-axis. All right, so that is positive 90. All right, if I want to graph negative 90, I still put the initial side to the right. So you'll always have one side to the right there. But negative 90 is what? Because it's negative, we're going to rotate clockwise. So clockwise, all right, is CW. So that means we would rotate down to the negative y-axis. And my angle would look like this. Okay? And notice the angles have the same shape. They both look like corners, but it's just the way they're positioned is the only difference. So they're really the same size, but they're in different positions. All right, let's try another one. All right, let's do 135 degrees and negative 135 degrees. Now, the one thing I always try to do, I always try to break up larger angle numbers in increments of 90, because I know what 90 looks like. 90 looks like a corner. So like think of 135 as it's a 90-degree angle plus a little bit more, 45 degrees. So I know I have to go at least 90 degrees, which means the angle has to be bigger than this one here. I need to rotate a little further, like maybe over to here in the second quadrant. So on the x-axis, we're going to put our start, which always goes there. And then the terminal side should be somewhere over here. Rotate it counterclockwise. So that would be 135 degrees if I rotate counterclockwise. So you notice we have a 90-degree angle in there, and 45 is half of a 90-degree angle. So I go about halfway into the other quadrant there. And that's about 135. Whereas I start here, and I would rotate clockwise. And that would give me the same looking angle, but notice it's like reflected the other way. All right, same size, but we're just rotating it a different way. All right, so for example, how about angles bigger than 360? Okay, so for angles bigger than 360, let's do an example just to kind of illustrate first. How would you sketch an angle that's more than 360? So let's do double that, all right? So let's do 360 versus 720. 720 is 2 times 360. So 360 would look like this. Now you got to think, this is positive 360, so this is going to be counterclockwise rotation. So we start there. We rotate 360 degrees. Remember, 360 is a full circle. So I would start and I would rotate all the way back to the beginning. And notice I don't have to draw a second side because the starting side and the terminal side are overlapping in this problem. Okay? So 360 degrees just represents that the angle goes all the way around once. What does 720 represent? That would represent the angle rotating not once, but 2 times around. Okay? So this is 360. So all you really have to do to draw 720, so we start there. And to show that you rotate 2 times, just start close to the origin. You go around once, but this time make it a spiral so you can show that you go around again. It just gives you room to work by making it a spiral instead of a circle. So I just did 1 rotation, and then I got to go all the way around again for 2 full rotations. So that's positive 720 degrees counterclockwise, which is 2 rotations. This is 1 rotation. Okay? Now here's the thing we want to compare. What is really the difference here? There really, there is no difference, but there is a difference. The difference is the number of rotations. But look at the way the arms or the sides of the angle are positioned. This arm here and this arm here, they're in the same exact position. All right, so let's write that down. There's a difference certainly, which is the number of rotations, but their similarity is more important. So we're going to put a star next to it because it's more important, is that 360 and 720 finish in the same position. Okay, they finish in the same position. So essentially what we'd say is that 360 and 720 in terms of position are equal. So this gives us an idea of how to work with angles that are more than 360. Okay, so let's make that note here. So for angles that are more than 360, you can get an equivalent angle that is between 0 and 360. By subtracting 360 if your angle theta is positive, adding 360 if your angle theta is negative. Now let me give you a minute there to catch up. And then we'll do examples of how we would do this. Excuse me. All right, so the directions here tells you to find an equivalent angle for theta so that, now this expression here simply means so that theta is between 0 and 360. All right, so this is a mathematical expression for this phrase right here. Between 0 and 360 is just this inequality expression. Okay, so let's say our theta is 415 degrees. All right, so the one thing you want to note is that theta is positive. So we would use rule A here to subtract 360, right? Because think about it, if you add 360 to that, it's going to become 700 something, right? And that's too big. So you got to really think about it logically, like, how do I get this to be between 0 and 360? I'm going to have to make it smaller because it's too big. So I would have to simply do 415 minus 360 is 45 degrees. So 415 degrees is really also 45. What's the difference? This is just 45 degrees rotated one more time all the way around. So how would that look? So we know that we'd have to start here. And 45 degrees would end up here. So let me put this here. That's 45. But if you rotate the top arm all the way around one more time, that's adding 360 to that. So that would really be this angle. That would be 415. But they're in the same position. So it's the same angle. All right, how about something really big like 1,000 degrees? We won't draw this one, but let's see if we can find the angle that's between 0 and 360, which is equivalent to this one, meaning it's in the same place. So let's do 1,000 minus 360. Something tells me this is not going to be enough, right? So you subtract 360, you get 640. Oh, you got to go again. Subtract again, you get 280. So sometimes you have to add or subtract 360 more than once until you get it between 0 and 360. All right, and we won't draw that one. 3, what if theta is negative 60 degrees? Right? Now remember, we want the angle to be between 0 and positive 360. So essentially, we're looking for mostly positive answers, unless it's 0. Okay? So what do we have to do here? Well, look at part B in the notes. All right, this angle is negative that I gave you, so we're going to have to add 360, all right? Because otherwise, if you subtract 360, that just makes it more negative. So that would be the wrong thing to do. So you add 360, and that gives you 300. So 300 degrees would be the equivalent angle. Let's sketch this one because it's a very common angle. So I would first draw my starting side. Let's first draw negative 60. So negative 60 would be something like this, right? It's a little more than 45. It's not quite 90. So, and it's clockwise. So that's rotating down is clockwise, going around like a clock. So that's negative 60. But positive 300 would just be rotating all the way around the other way in the counterclockwise direction. And notice they meet. They meet in the same place. And also, the one nice thing about the negative and the positive values, if you ignore the negative, all right, and you add that to this answer, it should form a circle. It should form a circle. Okay, one more. Number 4, what if it is negative 700 degrees? All right, so again, this is negative, so we're going to have to add 360. So that will give us negative 340. Now, is that between 0 and 360? No. So that means we got to add 360 again. And then that will do it. That will give us positive 20 degrees. So an angle of negative 700 degrees, it sounds really big, but it's no different than 20 degrees. It's a very small angle, just rotate it around a few times. And remember, it just rotates around a few times, and it just ends up in the same place as a 20-degree angle. All right, so now let's talk about radian angle measurement. If you like the number pi, remember pi? You're going to see that a lot in this. All right, so first let's define what a radian is. All right, so first I'm going to draw a picture of it because it makes sense when you look at it, and then we'll write it out in words. All right, so the word radian almost sounds like the word radius, and that's because they are related. So the radians are related to the radius of a circle. They're related to the radius of a circle. Notice it's almost the same word. All right, so let's take a look at this. So there's my best circle. All right, now what I'm going to do is I'm going to divide the circle in half, just because I only really need the top half for this. And of course, that's where I drew this thing the worst, but that's okay. I'm sure you'll forgive me. Here's the center of the circle. And of course, we have here that right there would be the radius, r. Okay? And then let's draw the radius another way. Let's draw it here. That's also the radius. And then notice that the radius contains this much of the circle. So it kind of forms like a nice pizza pie. This is what we want to focus on. All right, and we're going to call this S. All right, where we have S is the arc. The arc is a piece of a circle, right? So it's the piece of a circle. All right, that's being contained by those two radii. So that just means the radii are like two arms stretching out to hold both ends of the arc. All right. All right, now what we want to look at is the angle formed by those two radii. So do you notice something here in the diagram? I tried to make this purposeful. I'm sorry, on purpose, I should say, where the blue and the red are the same length. Can you picture that? All right, you know, the diagram's not perfect, but that's the illustration that I tried to make here, that the blue and the red are the same length. So that's what a radian angle measures. When you sketch an angle, which remember traces out part of a circle, when that angle is 1 radian, this is what happens, that the radius and the arc are the same exact length, no bigger, no smaller. All right, so let's write that out. So we say that theta equals 1 radian when the arc and the radius are of equal length. Okay, so that is the basic definition of radian measurement, but specifically it's 1 radian, 1 radian. All right, so when you make the angle big enough so that the radius and that arc are of equal length, we say we have 1 radian. Now, of course, what we want to figure out here is what's the relationship between degrees and radians. So I think for those that remember degrees well, this angle does not look like it's 1 degree. It's too big, right? This angle looks like it's about 60 degrees. So, and it's near 60, all right, in degrees. So obviously 1 radian and 60 degrees are not the same number. So we got to figure out what's the conversion between radians and degrees. So here's how we can figure this out. Let's say we were to continue this diagram. All right. Think of this wedge here as a slice of pizza. How many of these wedges do you think we could fit in the top half? All right. How many more slices of this size could I fit in the top half? Well, I'll tell you, it's actually just about 3. Don't go by my drawing. It's not perfect. All right. So we have theta equals 1 radian, 1 rad. Here we have theta equals 1 rad, radian. And here we also have theta equals 1 radian. Because they're equal in size, at least they're supposed to be. All right. So remember that a half a circle is 180 degrees. Or blank radians. So we have 1, 2, 3, plus a little more, right? And that little more is this little wedge here. That's almost half a circle, right? So this is actually about 0.4 radians. It's very small, right? This is 1, this is 1, this is 1. This is a little more. What number do you get when you add all these wedges up? 1 plus 1 plus 1 plus 0.14. You get 3.14 radians. All right, so that's pi radians. All right, so let me do this. Let me highlight. So if you add this all up, the top half there, the sum is 3.14 radians, which is pi. All right, so you add the 3 full wedges and that little tiny wedge of about 0.14 radians. All right, and that gives us a relationship between degrees and radians. So this helps us to convert degrees to radians, or also radians to degrees. You can do it both ways. Now, for those of you in the sciences, this will make a lot of sense with the conversions because you're used to converting like other values, right? Like kilograms, meters, milliliters. This is the same exact idea. So remember, the conversion factor is just a ratio of these two, like 180 over pi or pi over 180, and you multiply that to your number to convert it. So here's what I mean. So let's call this number 1. To convert theta from degrees to radians, you take your theta and you multiply it by pi divided by 180 degrees. All right, because pi over 180, remember these conversions here, these numbers are equal in their systems. So 180 degrees is a half circle, but so is pi radians, but they're on different scales. So in a sense, when you divide pi radians and 180 degrees, that's a unit value of 1. So for those of you that are good with your science conversions, that should make sense. For those that are not, just go by the formula. All right, so for example, all right, oops. All right, let's take some common angles like 45 degrees, 90 degrees. Let's also do 360. Let's see what those are in radians. Okay, so we first bring down 45 degrees, and using the formula there, we times it by pi over 180. All right, now, what we're going to do is we're going to write our answers in terms of pi. And I'll show you what that means in a minute. Well, what you want to do first is now think about this: 45 over 1 over 180. All right, so what you could do is reduce 45 degrees over 180 degrees. The pi is like, think of it as like a variable. It's like, think of it like x. You can just let it sit there. But what you need to do is work with the actual whole number values, 45 over 180. Could you reduce that? If you don't know how to do that, here's how you would do it. Type in your calculator, 45 over 180, hit enter, and then math frac, remember that? Convert a decimal to a fraction. Hit number 1, frac, and enter. So 45 over 180 reduces to 1/4. So then this, excuse me, reduces to 1 pi over 4. And also notice the degrees cancel, right? Because you have degrees divided by degrees. So these can drop out, right here. Notice I crossed out the degree symbols. And then 1 pi is pi over 4. All right, and this is what I mean. Write your answer in terms of pi. That just means just keep pi in your answer. Don't change it to 3.14. Leave it as the symbol pi. So pi over 4 is really pi over 4 radians. But the thing with radians, we don't actually write radians. We don't even write RAD. See, it's weird because with degrees, we put the degree symbol, but with radians, we put nothing. So really, we just write pi over 4. All right, number 2, let's do 90 degrees. So again, we just multiply the angle by pi over 180. So theta equals 90 times pi radians over 180 degrees. And you notice that 90 and 180, that's a half, right? So that gives me 1 pi over 2. You don't have to write the 1 there. If you know it's a 2 in the denominator, you can just write it as pi over 2. So pi over 2 radians is equivalent to 90 degrees. Let's do 360. So you would do 360 times pi over 180. Now remember, ignore pi here when you reduce. All right, just reduce 360 over 180. That's 2 over 1, 2 over 1, or 2, which gives me 2 pi. All right, because 360 over 180 is 2. So 2 pi radians is 360 degrees. All right, notice all my answers are in terms of pi. All right, now let's do the converting the other way. So number 2, to convert theta from radians to degrees. That means degrees is going to be your final answer, right? So what you're going to do is you're going to take theta and times it by 180 degrees over pi radians. And notice that this conversion factor is just flipped over from part 1. All right, from part 1, we had pi on top. All right, here we're putting pi underneath in the denominator so we can cancel radians. All right, remember, when you're converting, the value that goes in the denominator is what you're trying to cancel. So here we're trying to cancel radians, so we get the answer in the numerator, which is degrees. Okay, so let's do a couple of examples of how to do this. Number 1, What about pi over 6? So that looks like a radian angle because it involves pi. So typically whenever you see pi, all right, think radians. So this is radians. So that's my theta. We'll also do theta equals pi over 3. And then we'll also do theta equals 5 pi over 4. All right, so just take those angles and multiply them by 180 over pi. So here we go. So we get pi over 6 is the angle, times it by 180 degrees over pi. Now these conversions are nicer because the pi's always cancel. So pi over pi drops out. And then it simply becomes 180 over 6 in degrees, which is 30 degrees. All right, number 2. So we want to convert pi over 3 radians to degrees. So just bring down the angle, multiply it by 180 over pi. And of course, pi's cancel. Pi over pi cancels out. And do you see what's left over? It's 180 divided by 3, which is 60. All right, and number 3, if the theta is 5 pi over 4, what angle is that in degrees? So where 5 pi over 4 is radians. So we first just bring down the angle, times it by 180 degrees over pi. Excuse me. Pi's cancel. All right, now I'm going to do this a little bit of the long way, but I mean, feel free just to write out a final answer. So what are you doing on top there? You're multiplying 5 and 180, and then just dividing that by 4. All right, so that gives us 900 divided by 4 in degrees is 225. Now, this is all calculator math. I like to write it out because I try to not use the calculator to kind of keep my own mental math fresh. So if you just want to do this much on the calculator, you don't have to figure out all those little pieces. Use the calculator to do the pieces for you. All right. So again, I just like to do it on my own just to keep my own mind fresh, okay? To make me look smart as a math teacher, you know. All right. Okay, so now we're going to do our final groups here. Well, look at that. It's 9:04. I finished a little early tonight. Yay. You happy? So that means, since this is our last group work, you have the option now, if you want to sign off, you may do so. The lecture is officially over at this point. But you do have a number of problems to do for the rest of the lab. So if you want to stick around and we can just have one big group chat, we can do that. And you can ask me questions and I can help you out. But other than that, feel free to sign off. And then remember to upload your solutions by 6 p.m. tomorrow. So class is really officially over. So to all of you that are leaving, have a good night. And for those that are staying, I'll be more than happy to stick around and help you out.